The per unit system is a technique used in power system analysis to simplify calculations and comparisons. This is achieved by expressing all system voltages, currents, and impedances in terms of a common base value. This approach allows for an easy and direct comparison of different components and equipment, regardless of their actual values or ratings. One advantage is comparable calculations. The per unit system enables engineers to make meaningful comparisons between different sections of a power system or between different power systems that may have different voltage levels and ratings. Another advantage is simplified design and analysis. It reduces the complexity of power system analysis by converting all quantities to a common base. This eliminates the need to consider multiple voltage levels and impedance values simultaneously. The per unit system also offers flexibility. The base values can be chosen to suit the specific analysis or design requirements, providing flexibility in representing the system parameters. Now let's consider an example to illustrate how the per unit system works. Suppose we have a power system with the following parameters: a base voltage of 13.8 kV, a base current of 100 amps, and a base impedance of 13.8 ohms. The actual values in the system are an actual voltage of 11.5 kV, an actual current of 75 amps, and an actual impedance of 10 ohms. To convert these actual values to per unit values, we use the following formulas. Per unit voltage is calculated by dividing the actual voltage by the base voltage. In this case, the per unit voltage is equal to 11.5 kV divided by 13.8 kV, which equals 0.833 per unit. Per unit current is calculated by dividing the actual current by the base current. Here, the per unit current is equal to 75 amps divided by 100 amps, which equals 0.75 per unit. Per unit impedance is calculated by dividing the actual impedance by the base impedance. Thus, the per unit impedance is equal to 10 ohms divided by 13.8 ohms, which equals 0.725 per unit. By converting the values to per unit, we can now directly compare the voltage, current, and impedance. The per unit voltage of 0.833 means that the actual voltage is 83.3% of the base voltage. The per unit current of 0.75 means that the actual current is 75% of the base current. The per unit impedance of 0.725 means that the actual impedance is 72.5% of the base impedance. This simplified representation allows for easier understanding and analysis of the power system without the distractions of varying actual values. In summary, the per unit system simplifies power system calculations by normalizing values to a common base. This makes it easier to compare and analyze different components and systems.